All right, I say let's get this party started. Thank you so much for being here today. Good afternoon, and welcome to our Sustainable Solutions Environmental Speaker Series. My name is Cassandra Hansen, and I am the Program Director for the Environmental Sciences and Policy Program, as well as the GIS program at Johns Hopkins University Advanced Academic Program. Our Sustainable Solutions Seminar Series focuses on real-world problems and the deconstruction and decoding of these problems by practitioners, and how they're leveraging technology, policy, and public and private sectors to form long-lasting solutions for these problems. So before I introduce today's presenter, which I'm extremely excited about, I wanted to ask, for those that are here today, where are you coming from? So if you could just go ahead and put into the chat window where you're coming from, it would be great to see our geographic extent. So go ahead and find that chat window. Let us know where you're coming from. Excellent. All right, so this is great. So now you know where the chat box is, so feel free to provide comments in the chat box. If you have any questions throughout today's presentation, feel free to put those questions into Q&A. And at the end of today's presentation, I will put voice to those questions. So again, now you know where the chat box is, now you know where the Q&A. So I'm going to go ahead and get started on introducing today's speaker. So I just want to say thank you very much to today's presenter, Dr. Glenn Patterson. He's been with the ESP program for 17 years now teaching, and he's just a phenomenal instructor. So for the students that are here today, if you have not taken a class by Dr. Patterson, please do so. It's just an amazing experience, and he has such a wonderful and very diverse background. So a little bit more information about Glenn. He grew up in Maryland, where he became interested in water quality issues in the Potomac River Basin at an early age. He worked as a hydrologist with the U.S. Geological Survey for 30 years in California, Oregon, South Carolina, and the headquarters office of Reston, Virginia, and also in Colorado, where he resides now. He received his BA in biology from the University of Chicago, his Master's of Science in Watershed Management from the University of Arizona, and a PhD in watershed science from Colorado State University. And he's worked for 30 years, as I mentioned, as a hydrologist with the U.S. Geological Survey, focusing on water quality, watershed, drinking water, lakes, estuaries, and geomorphology topics. At the USGS, Glenn was involved in various water quality issues, such as long-term monitoring, watershed protection, drinking water protection, sedimentation, saltwater intrusion, and groundwater quality. As I mentioned, Glenn joined the ESP program in 2003, where he first started teaching face-to-face out of the DC campus, but then a couple years later was invited to start experimenting and playing around with teaching in the online platform. And so he's an amazing instructor and has done some wonderful things with his courses throughout the years. So courses that you may have taken with Dr. Patterson is our watershed management course, strategies in watershed management, drinking water, sanitation and health, and the global scarcity of freshwater systems, crisis and solutions. We're also thrilled to share with you that he will be organizing and designing a field course and teaching it in June that will take place in Colorado. Steamboat Springs will be the headquarters. And this course will focus on field methods in streams and water quality assessment in the upper Yampa River Basin in Colorado. So a lot of really interesting components that are happening there. Glenn and his wife live in Steamboat Springs, Colorado, where they enjoy a variety of activities. And I'm going to pause there because I want to make sure we have enough time for the amazing information he has today. So today's topic will be focusing on climate change, water quality, and health. And again, let's go ahead and give Glenn a virtual round of applause. Thank you so much for being here today. I'm thrilled to have you, and I'm going to go ahead and stop sharing my screen and turn over the presentation to you. Thank you so much for being here.
Thank you very much, Dr. Hansen. I'd just like to start by saying that aside from working on my own degree programs, being associated with the Environmental Science and Policy program at Hopkins has been my favorite academic exercise for these past 17 years. It's been really great to be associated with this program. And I appreciate the opportunity today to share some thoughts on this topic. So the topic is climate change, water quality, and health. Oh, and I should pause for just a moment. Does everything seem to be going okay technically?
Yes, we can see your slide.
Okay. All right, and I'll ask for the next slide when it's time to go. We're still on the introductory slide. The topic climate change, water quality, and health is of particular interest to me because it's an intriguing and somewhat understudied link in that important nexus between climate change and health. There's been a lot of work done, a lot of popular articles, a lot of scientific research on climate change and health in general. But the particular link that goes through water quality is of lesser renown, but also a lot of interest. So we can go on to the next slide. There, okay. And so that's why we've got this three-way nexus here among climate change, impacts of climate change on water quantity as well as water quality. And as most of us are already pretty familiar with, and we'll see in this presentation, water quantity is intricately linked with water quality. And then those further impacts of water quality on human health. Next slide. So what are some of those aspects of climate change that affect water, both quantity and quality? Of course, with climate change, with a warming Earth, we have increased heat and energy in the atmosphere, increased evaporation from oceans, lakes, and land, changes in atmospheric circulation patterns, such that we have greater swings in our local weather patterns, as we've been seeing last summer and this winter. Changes in precipitation patterns, drier in some places, wetter in others. Changes in patterns of snow and ice accumulation and melt. Increased incidence of severity, increased incidence and severity of wildfires. Changes in vegetative cover, rising sea level, and also an increase in water-related armed conflicts. So all of these are aspects that link climate change to water, and we'll see how these can also affect human health. Next slide. Looking a little bit more in specifics on how water quantity is affected by climate change, that increased heat, energy, and water vapor in the atmosphere and greater fluctuation in atmospheric circulation and the changes in snow accumulation and melt lead to an increased frequency and severity of both floods and droughts. And we've certainly been seeing that. And those droughts and the extra heat cause an increased incidence of wildfires, which brings the changes in vegetative cover. And those wildfire impacts lead to changes in the relation between surface water and groundwater. The changes in the soil after wildfire tend to decrease infiltration of water from the surface down into underground aquifers. And therefore, we see increased flashier surface runoff following wildfires. Next slide. And some of the climate change impacts on water quality. First of all, of course, water gets warmer as the climate warms. We see higher intensity rainfall, higher stream flow, increased flooding, and flashier runoff. Flashier meaning a quicker rise to a flood peak and a quicker return to low flows. And that generates opportunities for surface runoff to pick up and carry materials from the land surface during these flashy floods, including sediments and contaminants, especially in recently burned areas, because those wildfires leave a lot of materials on the burned ground that can affect water quality. On the flip side, droughts of greater frequency and intensity lead to less water available to dilute pollutants, and therefore higher concentrations of contaminants. And finally, rising sea level leads to intrusion of salt water into both rivers and aquifers. Next slide. So the next few slides will show a few quotes from some of the climate experts regarding some of these impacts on water, water quality, and health. Here's one from the Intergovernmental Panel on Climate Change. The frequency of heavy precipitation events will very likely increase over most areas during the 21st century, with more rain-generated floods. At the same time, the proportion of land in extreme drought at any one time is also projected to increase because of those swings in those greater swings in atmospheric circulation. Next slide. And here's a quote from UN Climate Action. Water and climate change are inextricably linked. Climate change affects the world's water in complex ways, from unpredictable rainfall patterns to shrinking ice sheets, rising sea levels, floods, and droughts. Most impacts of climate change come down to water. And the next slide. Here's another one from the United Nations. By 2050, the number of people at risk of floods will increase from its current level of 1.2 billion to 1.6 billion. In the early to mid 2010s, 1.9 billion people, or 27% of the global population, lived in potential severely water scarce areas. By 2050, this number will increase to 2.7 to 3.2 billion people. And regarding water quality impacts, here's one from the American Public Health Association. Warmer weather causes more water to evaporate, allowing the air to hold more water. This sets the stage for heavier rainfall and flooding, which decreases the quality of our water and increases health risks. A quote from the Environmental Protection Agency. Climate change threatens the quality of source water, in other words, water used for drinking, through increased runoff of pollutants and sediment, decreased water availability from drought and saltwater intrusion, as well as adversely affecting overall efforts to maintain water quality. So the water we have is of diminishing water quality, and it becomes harder to treat that water and protect the health of the consumers of that water. Next slide. This one from both the American Public Health Association and the Centers for Disease Control. Increases in precipitation extremes, either heavy rainfall events or droughts, can impact our health. Warmer temperatures cause more water to evaporate into the air and allow that air to hold more water. This sets the stage for heavier downpours. At the same time, global temperatures influence the way heat and moisture move around the planet, meaning drier conditions will occur in some regions of the world. Precipitation extremes create many safety hazards and health risks. So let's look at some of these examples of resulting impacts. I'm sorry, I didn't say next slide. Let's look at a few examples of resulting impacts on human health. Next slide. First, and maybe the most important, are waterborne diarrheal diseases. These diseases, and this, of course, has been of long-term interest at Johns Hopkins University, where the School of Public Health more than a century ago made some great strides forward in protecting people from waterborne diarrheal diseases. It's a side issue that we don't need to get in right now, but it's certainly a long-term interest issue at Hopkins. These waterborne diarrheal diseases kill 1.5 million children under 5 years of age each year, plus, of course, a lot of adults too. Examples include cholera, typhoid fever, dysentery, rotavirus, toxic strains of E. coli bacteria, and others. Climate change threatens progress achieved in global reductions of infectious disease rates over recent decades. And this is characterized pretty well or summarized in this review article by Levy, Smith, and Carlton in 2018. They summarize the literature on potential impacts of climate change on waterborne disease and show that a growing body of evidence suggests that climate change may alter the incidence of waterborne disease and diarrheal diseases in particular. Much of the existing work examines historical relationships between weather and diarrhea incidence, with a limited number of studies projecting future disease rates. Some studies take social and ecological factors into account in consideration of historical relationships, but few have done so in projecting future conditions. The field on this particular issue is at a point of transition toward incorporating social and ecological factors into understanding the relationships between climatic factors and diarrheal diseases, and using this information for future projections. The integration of these components helps identify vulnerable populations and prioritize adaptation strategies to help protect them. Anthropogenic climate change has caused increases in the number of warm days and nights and the frequency and intensity of both droughts and heavy rainfall events. This has implications for waterborne diseases, as high temperatures can alter pathogen survival, replication, and virulence. Heavy rainfall events can mobilize pathogens and compromise water and sanitation infrastructure. And drought can concentrate pathogens in limited water supplies. The Intergovernmental Panel on Climate Change states that there is a very high confidence that increased risks of food and waterborne diseases can be expected if climate change continues as projected across the representative concentration pathway scenarios through the mid-century of the 21st century. Next slide. And another example of waterborne disease affected by climate change is schistosomiasis. And here we see just a brief depiction of the complex life cycle of schistosomiasis. We'll get into a little bit more detail in the next slide. So let's go ahead and go to that one. It's also known as snail fever or bilharzia. It's common in East Africa, where it causes around 280,000 deaths per year. It's second only to malaria in causing morbidity. Symptoms include pain, bloody urine and diarrhea, problems with urination, liver fibrosis, bladder cancer. It's spread by blood flukes. There's an alternate host, a freshwater snail, which releases the free-swimming cercaria, part of a life cycle, that penetrate the skin of humans and migrate to liver and bowels. So people get into the fresh water, these cercaria get through their skin, they start making their way through different parts of the body and cause these symptoms, and it's a pretty nasty disease. Let's go on to the next slide. Oh, okay, and excuse me, with decreasing water availability, there tend to be reductions in overall water availability. With fewer water sources, the flukes and cercaria become more concentrated, and there's greater likelihood for contracting the schistosomiasis. Okay, a few other examples include dengue fever, Zika, and chikungunya. These are mosquito-borne viruses found mostly in warm climates. There's the quote there: emerging water-related diseases such as dengue and chikungunya and Zika are reappearing and impacting on the life of the deprived. And as such, the provision of safe water and health care is in great demand in developing countries to combat the spread of infectious diseases. Climate variability is heavily impacting human health all around the globe, in particular on residents of developing countries. Impacts on surface water and groundwater resources and water-related illnesses are increasing, especially under changing climate scenarios such as diversity in rainfall patterns and increasing temperature and flash floods and severe droughts and heat waves and heavy precipitation. Naturally, as climate warms, the habitat for these mosquitoes, which like warm climates, expands. And so these vectors and the diseases they carry are moving into areas where people have not been dealing with them before. And so that expansion of their habitat causes greater likelihood for contracting the disease with people who have not had experience with the disease before. Sometimes it's not just exposure to new diseases. Sometimes what we're seeing is delays in managing the work we're doing to try to protect ourselves from waterborne diseases. Here's an example from China, where by 2030, climate change is projected to delay China's rapid progress toward reducing water, sanitation, and health attributable infectious disease burden by 8 to 85 months. This is by an author we'll see later at the end of the presentation in the reference slides. So these slides will be available if you ever want to check out some of these references. They're included at the end. Despite China's rapid progress in improving water, sanitation, and hygiene access, in 2011, 471 million people lacked access to improved sanitation and 401 million lacked access to household piped water. Because certain infectious diseases are sensitive to changes in both climate and water, sanitation, and hygiene conditions, these authors projected impacts of climate change on these diseases in China in 2020 and 2030 by coupling estimates of the temperature sensitivity of diarrheal diseases and 3 vector-borne diseases and temperature projections from global climate models. And they projected demographic changes. This is how they got their conclusion that the progress that has been made is going to be delayed by that time period. The development delay summarizes the adverse impact of climate change on these diseases in China and can be used in other settings besides China, where a significant health burden may accompany future changes in climate, even as the total burden of disease falls due to non-climate reasons, due to, in other words, efforts to improve water, sanitation, and hygiene. Next slide. We've been talking about diseases. Let's talk a little bit about direct impacts of heat. Several of those include harmful algal blooms, algal toxins from those algal blooms or just from algae in general, and also hypoxia and associated death and decay of aerobic organisms. Certainly it's an environmental problem, but it also can turn into a health problem. Recent research suggests that the impacts of climate change may promote the growth and dominance of harmful algal blooms through a variety of mechanisms, including warmer water temperatures, changes in salinity, increases in atmospheric carbon dioxide concentrations, changes in rainfall patterns, and intensifying of coastal upwelling, and also sea level rise. So the growth of harmful algae may be favored over other non-harmful algae through a combination of mechanisms. The warmer temperatures create a competitive advantage for certain types of harmful algae. And salinity, although certain toxin-producing cyanobacteria are quite salt tolerant, temporary increases in salinity can also cause salt stress, leading to leakage of cells and the release of toxins that otherwise would have been retained in the organisms. Increases in salinity during drought conditions can also create favorable conditions for the invasion of marine algae into what are usually freshwater ecosystems. This is currently occurring in our southwestern and south central United States lakes, where marine algae or golden algae has been increasing since the year 2000, causing significant fish kills in inland waters. And of course, this can lead to some human health issues as well. Next slide. Now let's shift a little bit and look at some impacts of drought on human health. As we mentioned earlier, drought causes less dilution, meaning, drought leaves less water available to help with dilution and can mean higher concentrations of soluble pollutants. This can pose health risks to those who obtain untreated water from streams and lakes for drinking. It can also complicate treatment of source water in places where there are developed water systems and lead to more frequent violations of drinking water standards. And there's a citation there for that. Next slide. And going back to wildfire to look in a little more detail, wildfire, of course, causes a loss of living vegetative cover, which means that the sediment is more mobilized. It's not held in place by the roots of those plants so well. This leads to more erosion and deposition of that sediment somewhere downstream. Wildfire can also change the chemical nature of soils through the heating process to make them more hydrophobic, meaning they repel water. And this is what leads to a decrease in infiltration and greater and flashier surface runoff. Wildfire also produces ash and other contaminants from the burning process, leaves them on the ground susceptible to being picked up and carried by that flashier surface runoff. So water supplies can be adversely affected during the active burning of a wildfire and for years afterward. During active burning, ash and contaminants associated with a fire settle on streams, lakes, and water reservoirs. Vegetation that holds soil in place retains water, it's burned away. Rainstorms flush vast quantities of ash, sediment, nutrients, and contaminants into streams, rivers, and downstream reservoirs. As we mentioned, greater erosion and sedimentation. So this can impact drinking water quality. It can discolor recreational waters and can potentially contribute to greater incidence of harmful algal blooms because of those chemical changes. Next slide. Then with sea level rise, and I should, just as a disclaimer, I should mention this is not a photograph of a real place. This is a computer simulation of effects of increased sea level over many years. But at any rate, it's just to remind us that sea level is rising. Intrusion of salt water into rivers and aquifers can make source water too salty to drink. And we've already seen instances of cities and water utilities having to move their water intakes farther upstream to avoid saltwater intrusion, or to shut down their intakes temporarily, or to shut down wells that are now penetrating parts of an aquifer that have become too salty to drink because of saltwater intrusion from the ocean into freshwater aquifers. Finally, a little bit about armed conflict. Conflicts over water have, of course, been part of our history since ancient times, and it's amazing to look at the scope historically, geographically, and with intensity of water conflicts over the millennia. The Pacific Institute has done a great job cataloging these water conflicts over the centuries. As water becomes scarcer and water quality declines, conflicts become more frequent and intense. And impacts include direct health effects of combat casualties, of course, from the combat itself, as well as indirect effects such as population displacement, release of toxins, destruction of infrastructure, and even mental health problems from having to deal with the stress of war and its impacts on water resources. And of course, at times, some of these water conflicts actually involve intentional contamination of water, which of course can lead to health issues, as well as the terroristic effect of concern over those health issues for years. Next slide. Okay, with that, I'll bring the talk to an end. The next few slides just cover the references, And so I'll be happy to wind up the presentation and see what questions there might be.
Excellent. Thank you so much. Let's give Glenn a virtual round of applause. That was really wonderful. Thank you so much. One thing that I found as you were speaking, you just did such a wonderful job providing a complete synopsis of important scientific research, that really describes the nexus among climate change, water quality, and health. And I'm just curious, that our students come to the program with a very diverse background from various disciplines. And how should they take this scientific information that you've shared with us, and how should it be used to inform policy decisions, or that aim on protecting, or improving population and health, or even just kind of water quality? What do you suggest?
Okay, well, thank you for kicking off the questions, Dr. Hansen. And I'm glad you brought that up, because one of the things that really excites me about this program is that what we all share, even though we come from diverse backgrounds and we emphasize different fields of science and policy, what we all share is that link or nexus between science and policy. How does science inform policy to help improve things in the world? And so some of the ways in which the science we've been talking about this today can inform policy and help to help us take steps to improve things. First of all, includes just being aware of these connections that we're talking. We can raise our awareness that climate change affects health in many ways, including those we've been talking about that involve water. Second, with this greater awareness, it can remind us that we need to keep an eye on things. We need to keep monitoring. We need to maintain our monitoring networks and programs for water quality and water quantity, as well as the climate change indicators themselves, and as well as human health indicators, so that we can just keep a handle on the situation and know what's happening in our changing world. Third, of course, is things we can do to just help improve the climate situation in general. We can take actions that we've all been reading about in the popular press and elsewhere to try to mitigate the overall greenhouse effect. And fourth, we can use these scientific studies to help inform adaptation strategies. Knowing what kind of conditions to expect can help us to take steps to mitigate the symptoms that we've been talking about, to get ahead of some of the problems, to know what to expect, so that we can form adaptation strategies to help protect human health.
Thank you. I'm going to pause and just let the community feel free to put your questions in the Q&A, or if you want to put it in the chat, you're welcome to do so. I have many questions, so I can keep asking them from here. But I do have a question. If you spoke to yourself 30 years ago, as you were starting your job as a hydrologist with USGS, anything that you would suggest or advice that you would give yourself to the you 30 years ago, where you should focus on, or things to be aware of?
Well, over those 30 years, a lot of the USGS leaders mentioned one of the things that I just mentioned, being in protecting our monitoring programs. And I guess I would just, they gave good emphasis to that as far back as 30 years ago. So I guess I would just emphasize that even more, to say we need to maintain our water monitoring stations, our stream flow gauges, our water quality programs, and keep those going, because a little bit of a gap in those programs leaves a statistical gap that you can never refill if the data are not there. In addition to maintaining monitoring programs, another exciting step forward, which probably would have been good for me to be mindful of back then is the incredible advances in technology and just monitoring strategies to bring new tools to bear to help us monitor more effectively. And just things like, monitoring indicator bacteria to indicate the likely presence of pathogens 30 years ago used techniques that are still used a lot today, but now with new biochemical techniques, it's possible to get a handle on pathogens and indicator bacteria so much more easily and so much more quickly. And we'll actually be going into this a little bit in that field course you were talking about. So I would have told myself back then to watch out for these opportunities for improved technology to help with our monitoring programs. Maybe that's a good place to stop on that question.
Yeah, thank you. Thank you. I know that was kind of a little bit of a curveball there, but it's always interesting to get a perspective on, what have you noticed over time and what advice you would have told yourself or things to look for. Dr. Zachary posted a question in the chat, and he said that the Supreme Court is deciding the regulatory power of agencies to protect us. Do you see this as an imminent issue or immediate issue or problem considering water?
Yes, indeed. I'm pretty nervous about this upcoming decision that we're likely to expect, having to do, well, I mean, the particular subject matter at hand is fisheries management, but there are implications for the federal regulatory control or programs or approaches that could broadly impact many regulatory programs throughout the government. We're at a critical time politically in this country where our regulatory structure is under attack, and the conflict between perceived human freedoms and the need to protect people and the environment from harmful substances is at a high point we haven't seen really in my lifetime. And it's a little scary. I mean, you just look at the precautionary principle, for example, in Europe, the precautionary principle says, and this is widely implemented in policy throughout the European Union, if somebody wants to introduce a chemical into commerce in Europe, the burden is on the producer to show that that chemical is safe. In this country, the precautionary principle has never been so strongly relied on. It's more of a matter of somebody has to show that there's harm in a chemical after it has already hit the market before the government will act to protect it. We do have a pretty good regulatory structure in place for drinking water contaminants. I got a chance to participate in that along with the EPA to some extent, and I was very impressed with the scientifically based approach that EPA used to identify new and existing drinking water contaminants and protect us from them. But that's all under attack through examples like this court case you brought up and other examples too. So yeah, it's a concern. Okay, go ahead.
A question that I have, or perhaps an additional speaking point, is, I see quite a bit of new students on the roster here and in attendance. And so I was wondering if you could just provide a little bit of a summary about the field course that we've been putting together and that you'll be teaching this summer, just to kind of give a little bit of overview. That'd be great.
Okay, well, we expect this to a group of about 12 students here in Steamboat Springs from around June 11th to 21st. And we'll be looking at the field methods for water quality and stream assessment. So we'll be, doing hands-on monitoring with some examples of some of the monitoring techniques we've been talking about, both, for stream geomorphology, for some of the biological indicators like benthic invertebrates, bacteria, and some of the chemical indicators of water quality. And at the same time, we'll also be looking at examples of how science informs policy here in the Upper Yampa River Basin. So it's going to be kind of at the micro level, looking at how we monitor water quality in streams, and also at the more macro level, with the help of some very interesting local people who are involved in these issues, we'll see how the type of science that we develop in these monitoring studies and in research programs helps to inform real world policy issues. And we'll get out on the river a little bit too.
Yeah, excellent. Oh, that's fabulous. So I'll pause here, and is there any other additional questions that the folks would like to ask? This has been wonderful. And, since the semester hasn't started yet, for students that are joining this week, it's a great way to kind of start warming up the brain to start thinking of environmental issues before the semester starts. So this is just really wonderful. Thank you for being here today.
Oh, you're so welcome. And as far as the crowd, I am impressed with how many people are here, and I recognize some names from some of the courses. So shout out to those students like Chris Simmons and others who have participated in some of these courses.
So my last question for you, since we have students here, would be advice for students that are wanting to, they join the program, they perhaps come from a financial background or a different background that's not environmental sciences or policy. What's the best way for them to get into the industry? How do they get their first job within the sciences or policy? What recommendations do you have?
Well, that's one of the enticing and fortunate aspects of the current situation. You've heard me kind of wail and moan about some of the hard challenges we're facing now, but this is a good time to be looking for employment in the environmental field. Consciousness is being raised. There's a lot of awareness out there on issues related to climate change, water, and health. Sure, there are challenges, and there's some political challenges that need to be overcome. But the fact of the matter is, there are a lot of positions available in many still in government, and if not at the federal level so much, then certainly at state and local levels. A lot of folks in my age cohort are retiring, leaving some vacancies that need to be filled with enthusiastic younger people. And the private sector has a lot of increasing awareness of these issues as well, and they're hiring. And then there are also great possibilities in the academic sector as well, and in nonprofits. So I think this is an exciting time to be looking for a career.
And actually, that's great that you mentioned nonprofits, because Nicole was wondering if you could think of any specific nonprofits or names that are working within this space that comes to mind.
I would be happy to send a list of some of the top ones I can think of. There are so many. Well, I'll mention Water for People for one. I think I've really been impressed with their work. They not only do the typical thing of going to developing countries and helping build their water infrastructure, but they also build social and economic systems to help with local investment in every sense of the word. People become invested in something when they care about it. It's not just a matter of money, but they help to build these local economic and social systems so that people care and understand and can take care of those infrastructures without having to just say, oh, you put it in here, it broke, and now we can't use it anymore. But they take over responsibility for them. So Water for People does a great job. But that's just one of many, and I would like an opportunity to just go ahead and send a list of some others that I think do a great job.
That'd be great. Thank you. One of our new students that joined the program, Alexandros, he posted a question. So thinking about when you were talking about wildfires, He was wondering if the hydrophobic erosion, which may or may not be rich in carbon, can one utilize the carbon in that process similar to reverse osmosis? Are you aware of that happening?
I can't say I'm aware of it happening. I think of some examples like, well, here in Colorado, there was a fire called the Hayman Fire, which at the time I think was the largest and hottest fire in Colorado's history. That was, something like 10 or 15 years ago. And since then, they've had even worse ones. But the Hayman Fire burned right in the watershed for one of Denver's big reservoirs, and washed a huge amount of carbonaceous sediment into the reservoir. I don't recall seeing anything about that sediment being treated as a resource. All I can recall is it caused a lot of problems. But I think that's a good question and something that could be looked at. Carbon is not quite as valuable as other commodities like metallic ores, so it would probably take a pretty rich sediment to be worth trying to do something with, but maybe it could happen. So good question.
Excellent. Well, I think we're at kind of a stopping point. Again, I want to thank Glenn for being here today. It was really a great discussion, and you shared a lot of wonderful resources. And so what we'll be able to do is we'll be able to share additional links that Glenn's going to send us. We'll be able to send that to folks that are attending today. So just be on the lookout for that email. So let's go ahead and give him a virtual round of applause. Thank you, Glenn. And then I also want to share with everyone here that, be on the lookout for the next invitation for our speaker series in February. So again, it's a wonderful opportunity to come together and hear what folks within the program and even outside of the program are doing. So again, with that said, I want to wish everyone a happy and healthy rest of the week. I look forward to seeing you during office hours and seeing you in class, and feel free to reach out if you have any questions. But thank you, Glenn, for being here today, and thank you for everyone that attended.
And I second that. Thank you, everyone, for the opportunity to speak today.
Take care.